A barrel assume uniform of radius 0.3 meters. Is at the corner of a step of height of 0.1 meter. If the barrel has a mass of 100 kilograms, what is the minimum force required to be able to roll the barrel up the step? Now this is a torque problem. So torque of getting this up the step is equal to torque of the push. So torque, we'll say torque of the push equals torque of the step. SG, we'll say step gravity. Now what we need to do is we need to find the torque of the push. So the torque of the push is going to be F, and you can't just push in the middle, so it's F times the radius, so F times 0.3. Now the torque of the other one is going to be a bit different, so we'll put dot 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 for now. So the way that we solve for this torque is we're going to take this. We know that our radius to this point is going to be 0.3 still, because we're still using radius, and the last radius was 0.3. And then finally, we'll have that. So we're able to find that this is 0.3. This is 0.3 minus 0.1, so 0.2. And we're able to find this last side, which we'll call x. So then force is 0.3. Force times 0.3 equals x times the mass times gravity. So now we solve for x, and it's your triangle is set up like this: 0.3, 0.2. And our final side, if we do Pythagorean theorem, is going to be 0.224 meters. So now we do 4 times our mass, which is 100, times our gravity, which is 9.8. You're able to solve that and say 0.224 is 0.3. 100 times 9.8 is our final answer. So we'll do 0.224 divided by 0.3 times 98. And then what? 100 kilograms times 9.8. Oh, 980, jeez. What am I doing? So our final force is going to be 731.733 newtons of force. Problem honestly isn't too bad. And I believe that is the only one I need to do for that quiz that I've done, because I'm just reviewing quizzes right now from the past before my unit test. So now the next problem says calculate that. So yeah. Ugh. So this one says a uniform plank like this lies on the edge of a table, hanging slightly off. and it has a distance of 1.8 meters from the end. And it has a distance of 4.2 meters this way. Now it's asking how much mass can be placed at the end before it tips if it has a mass of 30 kilograms. So essentially the way that I think about this problem is essentially this is just our tipping point right here. So we have our 1.8 and we have our 4.2. Now, the only other thing we have is that the mass is 30 kilograms. Now, we know for any uniform object, and this is a uniform plank, we know that it's located at the very center of the length. It's L over 2. So center mass, so it equals 6. So now we place this 6, and this entire thing is 6 long. So right here is going to be 3. Because if the center of mass equals 6 over 2, then and this length on one side is going to be 3, but on the other side is going to be also 3. Sorry, that makes no sense. But on this side you have 3 minus 1.8, and that'll give you how far away it is. So it's 1.2 meters away from this way. So essentially it's 1.2 meters that way for that weight. So that's all we actually need to know. So now if we set up a system of 30 kilograms times 9.8, of course, to get the force, is a distance of 1.2 meters away from the pivot point. Now on the other end, it's asking how much can we place on the other end before it tips. So if we look, it's 1.8 meters away this time, times our new mass, and we get that our final, times gravity, by the way, times 9.8. So these 9.8s actually cancel out. So you essentially do 30 times 1.2 divided by 1.8, and you get that 20 equals the mass, which is correct. Oh, sorry, that's all one problem. We'll put a dotted line in here so that we know. Okay. So these problems are all static friction based. Yeah. So the next one says a 12-meter boom, AB of a crane lifting 3,000 kilograms. Load is shown below. The center of mass of the boom is at its geometric center, and the mass of the boom is 1,000 kilograms. For the position shown, calculate the tension T in the cable. Okay, let me draw the crane. So this is a crane. Or a crane type vehicle. Here is our little tension cable we'll connect that to that end. We'll say that theta on this side equals 10 degrees. And then right here, theta equals 30 degrees. Now on this end you have we'll just say a wrecking ball. It's technically a metal beam, but we'll say it is 3,000 kilograms. And the actual boon itself is 1,000 kilograms. Now, it's asking what the tension is at this point T, or what is the tension supporting the rod. So we're going to take that, and we're going to say